Welcome back to Summarize Science. Today, we're looking at a fascinating paper that uncovers a hidden connection between two of the most powerful types of AI for creating images. On one side, you have autoregressive models, or VAR, which build an image by starting with a low-resolution sketch and progressively adding detail. On the other side are diffusion models, famous for starting with pure noise, like TV static, and gradually refining it into a stunningly realistic picture. These two methods seemed quite different, but researchers at Johns Hopkins University discovered they are secretly two sides of the same coin. Their paper is titled "Scalewise VAR is Secretly Discrete Diffusion," and it presents a groundbreaking insight. They found that if you make a small change to how the VAR model works, it becomes mathematically identical to a diffusion model. Specifically, they made the model Markovian, which is a fancy way of saying it only needs to look at the immediately previous step to generate the next level of detail. The researchers named their reimagined model SRDD for scalable visual refinement with discrete diffusion. So why is this connection so important? Because it allows them to take all the powerful tricks and optimizations developed for diffusion models and apply them directly to their new SRDD model. This creates a kind of best-of-both-worlds scenario, combining the efficiency of one approach with the proven techniques of the other. The results are immediately obvious when you look at these side-by-side comparisons. In tasks like image generation, in painting, and super-resolution, their model, labeled ORS, consistently produces clearer, sharper, and more coherent images than the original VAR model. They also ran extensive tests to prove its superiority numerically. As you can see in this table, their SRDD model achieves better scores across 4 different datasets compared to the original VAR and other popular generative models. This means the images are not only better looking, but the model is also more efficient and converges faster during training. What's truly impressive is its zero-shot performance. Without any extra fine-tuning, SRDD is better at complex tasks like filling in missing parts of an image or extending a picture beyond its original borders. For example, when repairing this image of a school bus, their method restores the yellow guidelines much more sharply. And when making a face image higher resolution, it yields crisper skin details without the blocky artifacts seen in the baseline model. So, let's quickly recap what we've learned. This paper established a fundamental bridge between autoregressive and diffusion models, two major families of AI image generators. By reframing the VAR model through a diffusion lens, they created a new model, SRDD, that is both more efficient and produces higher quality images. This work doesn't just improve one model, it opens up new directions for research. It suggests that the future of AI image generation might lie in unified models that combine the strengths of different approaches. This brings us one step closer to creating more scalable, efficient, and powerful tools for visual creation. That's all for today on Summarize Science.